Okay, so this is still 6.2, lesson 6.2, and this is the page where we're doing a page from the book, from page 223. And the problem says construct triangle ABC with base AB equal 11 centimeters, and AC is 9 centimeters, and BC is 7 centimeters. And I went ahead and constructed my triangle because I didn't want this video to be even longer, so you might want to stop the video and construct your triangle before you continue. All right, and now we're going to do the rest of the construction. It says construct the line that bisects C. All right, so angle C is right here. And we're going to bisect the angle. Remember, if you want to bisect an angle, all you have to do is just open up your compass to any amount you want and cut through, make an arc like that. Then go to each place where the arc intersects the sides of the angle and make 2 arcs like that, and then you have bisected the angle. So you're just going to connect the vertex of the angle through that place where those 2 arcs intersect. You should know that. Alright, so we bisected this angle, which means that these 2 angles are equal. Actually, yeah. So these 2 angles are equal. We know that now. Alright, next thing, construct the perpendicular bisector of CD. Alright, so the perpendicular bisector, oh whoops, I'm sorry. We're supposed to call the point where that bisector hits AB, we're supposed to call that D. Okay, so we are going to now make the perpendicular bisector of CD. Alright, to do that, you can open your compass to any amount you want, and you're going to start at one end of the segment, make an arc this side and this side. Then you're going to go to the other end point of the segment and make an arc here and here. Oops, that was not good. Ugh, sorry about that. Okay. So, here's your perpendicular bisector of segment CD. Alright, so perpendicular bisector means that these are right angles and that these 2 lengths are the same. Okay, so next it tells me to let E be the point in which the bisector intersects AC. So we'll call this E. And let F be the point in which it intersects CD. So this is F. And let G be the point in which it intersects BC. So this is G. And then we're going to draw DE and DG. So DE right here, and DG right here. Okay, now it's going to ask some questions. How many right angles are in the figure? The right angles are all right here where the perpendicular bisector cuts through that angle bisector, so that there are 4. Why is triangle CFE congruent to triangle CFG? All right, well, we know that these 2 angles are equal because this was an angle bisector. We know that these 2 angles are equal because they're right angles, and right angles are equal to each other. And then the 2 triangles share this side, so that's angle, side angle, is the reason those are congruent. All right, why does EF equal FG? So EF equals FG because corresponding parts of congruent triangles are congruent. Why are all 4 triangles surrounding F congruent? All right, well, we know that these 2 triangles are congruent, so we've got all these sides and all these angles that are congruent. All right, and then we know that So all four triangles have this equal side and this equal angle. They all have the right angle, and then they all have these two sides that are equal. So it's side, angle, side, that they're all congruent, all four of these triangles. Why is it that CG, so CG equal to GD equal to DE equal to EC, and that's because corresponding parts of congruent triangles are congruent. And then the question, why is CG parallel to DE? So we want to know why CG, so I'm just going to elongate that line. Why is this line parallel to this line? And that is because, oh, I forgot to mark the rest of the angles here. So these two angles are equal to those two angles, and then these two angles are equal to those two angles because of corresponding parts of the congruent triangles are congruent. So you can see that you've got these two lines, and if we think about this, or actually this as a transversal cutting through those two lines, you can see that alternate interior angles are going to be equal. So we can say alternate interior angles are equal. And then it asks, is EG parallel to AB? And the answer is no.